Appreciate your time, ladies and gentlemen. I have about an hour-long talk here. Listen, it's going to distill it down, move quickly. Jarrod Weiss with Yukon Technology. What we do is we treat water, and now we treat water to be reused, whether for an outfall or to whether it's going to an outfall or reused in the process. And we're going to talk more about being reused in the process in terms of CCR here. This is what we do. We're an equipment provider, an operations and equipment provider. Also, service stable, veteran-owned business. So if that, for those that contracts, that sometimes matters to those as well. And our approach is very much a collaborative business approach when we come to a customer. Design the right system for you and to achieve the results you desire out of it. Plenty of experience. Low flows, high flows, mechanical dewatering, the chemistry side of dewatering. We do it both. My experience, why I'm here today, is more on the mechanical side. I know enough to be dangerous on the chemistry side as well, doing iron and copper, but there's other people in the organization that are better at that than I. So if you have more of the strictly water treatment side, I may get out of my league a little bit. I'm more on the mechanical side. Plenty of projects. This is kind of out there where we're doing water treatment. Kind of the water treatment side out there and the various things we do out for the power industry. But that's more on, again, the water chemistry side than the solids dewatering, the mechanical dewatering of the ash. So what we saw when we came to the market, we typically, and the equipment we have is used in various other applications as well, whether it be tunneling, micro-tunneling, horizontal directional drilling, oil and gas drilling. It's those types of things that the mechanical process is there. It's been used for decades. The equipment is very well proven. We know all of what this equipment does. It is just new to the CCR world in that with new regulations and new criteria and new things coming out, bringing technology from these other markets into the CCR and utility world. So it's not necessarily new, just new to us. So what is this equipment? Few pictures. Most of my presentation is going to be videos. I don't have as many charts and graphs, so it's a little more videos, hopefully an after lunch presentation. So on your left, we separate particles by size, mostly to dewater and dry them out. What we do, so on the mechanical dewatering and the water treatment side, is we take dirty water or watery dirt, where it's mostly dirt, and take the dirt out of the water. So different than a straight water treatment job where it is by far water and we're talking TSS, ppms of dirt to get those. We're talking it's mostly dirt. We're talking 70-30, those percentages. And we're drying that dirt out or drying this ash out in our application in order so it can be hauled from one site to the other or to the landfill or wherever it needs to go. And it's not spilling out. So on the left, we'll separate the big particles with the machine on the top there, and then it cascades down to the, if I have a laser pointer, maybe not, cascades to the machines on the bottom, and then goes through hydrocyclones. So we'll get down to about sand-sized particles, 74 microns, with just screens, and then we'll go down to 43 microns in your silts and your clays, your fly ash, bottom ash, to use our terms, down with the hydrocyclones. To get down below, we'll use centrifuges, but we'll use plate and frame presses or belt presses. They're always, all those pieces of equipment are very much brothers and sisters in the same family when you look at it from a particle size range. We'll also use chemistry as this process bleeds down into the water treatment. We'll use chemistry, coagulants, flocculants in order to put them into the equipment and enhance that solids capture as well. So that's where those two kind of disciplines between the mechanical and the chemical start coming together. Again, collaborative approach, do things up to thousands of yards per day in terms of drying out the solids, and we'll go through, I do have a couple charts with math on them, and basically numbers to show what we produce and the equipment out of. Typically what most ash ponds are dewatered. You'll have so as we say it, we are a tool in the kit bag of the ash pond closure. We are by no means, we are the whole toolbox. We are one size wrench. That is what we are. We are usually a subcontractor to a general contractor in this market. we will work with that general contractor and the owner in a particular aspect where the ash is usually submerged underwater. So in order to handle that problem, typically the market right now pumps off the surface water. It may go through some water treatment, it may not, just depending on, and then out the door up to, you get close to the ash, then you start having to put in deep wells and shallow wells, and you actually draw down the water table so the general contractor can dewater and work in the dry. That then leads to a situation like this where you have well points, conveyance lines, and it can inhibit movement in and around the project site, as well as more things that can fail, freeze throughout the project. When you have to deal with your water, now that water goes, it can go to geotubes. That's sometimes used, as David mentioned earlier, very low cost option. You have to have time and space in order for those to work. And they do work, and they work fine. We use them as well. But when you don't have time or space, you need to use a mechanical separation process. That water treatment often then has a bigger system because you're continuing to drop down that water table, and so you have to have a greater water treatment footprint in order to treat all the thousands of gallons you're producing throughout the lifetime of the pounding, the closure. We propose the dredging, sluicing, and separating it, and then you can treat it. And you can either treat it partially or send that water back to the pond to grab the next pound of ash. So we'll use it either dredging of some sort, whether mechanical or hydraulic, in order to get that ash moved, can sluice it, and then separate it out in the mechanical dewatering process. Can also then, that slipstream of water can then be treated for what it needs to be to go out the door. Again, as I mentioned, new to us, not new to the market. So here's us on an ash pond closure. These are small pieces of equipment, the smallest we could put out there. So just kind of relative scale and size, this is really, really small. And I'll show you some pictures of the big stuff. So what we were doing here is, you see that river and the inside, the excavator is going to mechanically dredge that out, put the ash into the top of this hopper here, drop it in the top, we'll shake it below it, we'll remove the big, I call them the cats and the dogs, the big stuff, which is really, for us, greater than 1 millimeter. And then we'll take smaller than 1 millimeter, send it over to this small plant, hydrocyclones over a vibrating screen, pull that on the side, and we're taking essentially liquid ash, drying it out in a very continuous process. So that is what we're doing. The majority of the rest of this presentation is all videos. So the criteria we were asked to meet was a 30% dryness. I'll get into some of the criteria as well, and then they also said, okay, how big can you make these things? And we knew the size of our equipment, what it could do. The customer wanted to see it themselves, which understandable. So here's a picture of it, and to set this up, and I am going to go, hopefully this video plays. So this is what I'm trying to do here in this montage of videos for here is put you a day in the life out on the project. This is one day, one morning, as we're taking videos of that process. You couldn't all be there, so I am bringing it to you. This is not a collection of best of. You're going to see the same excavator, same bucket, doing the same thing. So you see everything as if you were standing there. Excavator pulled it out of that river that's in there and put it in this cell for it to then be fed into the piece of equipment. Actually, it will move forward. Sorry. Piece of equipment, the long reach is now above the big screen, and you're going to see it dumping into the top of the hopper. You see the solids mechanically falling off the trigger relative to dry. How dry is how much you see it coming off. This was not the workhorse piece of equipment. It is big, there's not a whole lot coming off of it. What it's meant to do is to get back to the dog, reduce the weight on the This piece of equipment, again, small, but this was the workhorse. So you're looking at particle size 74 microns to about 43 microns down in that size. Silts, clays, below sands is where we're looking and capturing at this point. Hydrocyclones over a vibrating screen. You can see the particles coming off the end. You can see them stacking up. With that drive, that same day, that excavator is right now loading that other side. That wet excavator goes on, and that is coming out the other side, and those size particles. Here's another view of the same thing. It actually looks like it's a liquid coming off. That's because that screen is vibrating. So it's taking the liquefaction of what ash does when it's vibrated. It wants to move and slide and move. We take advantage of that in order to actually dewater the ash. You see the little chips falling below. You don't see a grate because it's actually stacked up so high in this video. And here, what I want to draw your attention to is the excavator is going to actually boom around into the view. You're going to see it scoop the ash from right here, and you're going to see the edge actual hold on as it scoops it out. So you can see within a few minutes that excavator was the wet flowing ash is now it's scooping out the dry ash a few minutes later. See the consistency of that ash can now be put in the back of the truck and hauled down the road. To operate the excavator, above, you can kind of see him there. In the interest of time, that was about 5 minutes of me doing this, or of our guys doing that. I'm going to spare this video just in the interest of time. And get to the data. So this is a different day. You just see both of the machines working together. You see it stacking up there, and then you're going to see it pan over and coming out the other side. So it's a continuous process. This was a mechanical dredge, and we only went down to about the 43 microns because that's what the customer wanted. They didn't want to introduce the hydraulic dredge. They didn't have that out there. They said, look, we'll mechanically do it, and this is how they were doing it. So the data portion, I call it the nerd part of this. The engineer comes out in me. 5 samples. We had discard from the fine screen, the coarse screen, the loadout pile. So what the loadout pile was is this customer is actually doing beneficial reuse. So they were hauling it from one state to another. That was what they called the loadout pile. And so that was the gold standard. We had to really pull that 30% moisture number out. Like, what is the standard? I want something analytically that I can, whether I succeeded or failed, I want to be held to that standard. We really had to pull that 30% out when we got on site, since they were doing the overland trucking. I wanted to get a sample of that, because if I could meet that data, whether I met your 30% or not, that's what's actually being used. So target 30%, again, independent lab in terms of testing. So what the loadout pile, about 17% moisture in that. So fairly dry, that's what's going out. And the whole reason this customer was out there is it would rain on them, and then they would start at day 1, and it took them about 5 days to get the ash dry enough to where they could drive it out. And so if it rained anywhere in those 5 days, they were taking backward steps in that. So that's where the mechanical process was helping them out. Immediately off the core screen, bigger particles have less water. We were meeting our 30% criteria, but not quite what that loadout pile was. And on the fines discharge, we were just less than 1% underneath that 30% target with just the fine particles right there immediately off the screen. After 12 hours and 36, why we had those numbers out there. The thought process is the general contractors out there working for a day, they're going to create piles, and then they will load them out the next day. That would be about a 12 hours from the end of shift one day to the beginning of the shift the next day. That was 12 hours, roughly. So we wanted to know Mother Nature's going to take do her thing, especially overnight, which is when these samples were taken, to show that. So that's the dryness of just the fines after 12 hours. So we were within a few percent of meeting that exact loadout pile that took them multiple days when all they could do was in the next shift. We did a 36-hour again. We didn't know the answers to the test before we took it, so we did a 36-hour as well. Granted, the numbers say it's drier than the loadout pile, but I'll call it that about even. We're within a couple samplings there. So took from 5 to 7 days down to a half a day to a day when you think that 12 to 36 hours. So significant savings in terms of time for that contractor to be able to load ash out. Since it does separate by size, this does, in some instances, we can separate the bottom ash from the fly ash if that gets used for some beneficial reuse. Some people really like that, some people really don't. And then scalability design, again, as I kind of mentioned, proven technology. We know the equipment. We put these systems together, and you just scale it based off size, looking at the particle size distribution. What are those size? What rates do you want to produce at? And we build a system, and we build systems similar to this one. So this is one that we built as well. So sorry I've condensed that. I hope you listened quickly. Are there any questions? So again, more mechanical dewatering of the ash, a tool in the kit bag. By no means do we think we are any more than the instance when it's really wet. Yes, sir.
First, can you speak to like tons per hour roughly that the pile was generating?
So that one was generating at about 90 tons an hour. 90 tons an hour, if I remember correctly. So, but again, we would just, if this customer said, hey, we want to do with the 6,000 cubic yards, we would, okay, there's more machines. And again, those were the smallest ones in order to just be cost effective.
And then
Yes, sir.
the question was the particular type of ash pile you're dealing with, is it bottom ash, fly ash?
It was a mixture of both, and I'll be honest, that was not FGD, but again, we can do FGD because it's separating particles by size. Sometimes it matters whether they're sticky or not. We get problems with chicken feathers randomly because they're wire screens, but we don't have too many chicken feathers in ash ponds, so I think we're okay. But we do have solutions for that. So that's what's nice about the mechanical side is it's really separating particles by size or density with the hydrocyclones, where when you're doing a straight water treatment, the chemistry really matters a lot. So, correct. And again, when we were out there, which type of ash and when it was, and all those things matter, and they knew that. I did not know that. Yes, sir.
What stage do you guys are working on to do these types of?
Yes.
Anyway.
Anyway.
Okay.
We ship it, again, kind of going back to that picture. Most of them are pretty mobile. We'll erect them on site, put them together. Some of them are, like this one's, I'll be honest, a pretty slick one. So you're going in like less than a day. But some of them you take about a day, day and a half to put together when you hook up hoses and things of that nature. So pretty darn quick from a mobilization perspective. And usually built within tanks and containers and hose things together so they can be traveled down the road. Appreciate it.
Wait, I have another question.
Oh, yes, sir.
Thank you, Jarrod. Great. It's really helpful to see visually what's going on in these processes. Kind of thinking again about the legacy rule in some of the ponds that may not have been as segregated as they are now for beneficial use purposes. So old ponds that may have had a mixture of scrubber solids, which are generally really fine, and fly ash with bottom ash. And you'd mentioned that you're screening it sometimes.
Yes.
Heterogeneity in these ponds could be a real problem. I'm just wondering how you handle a situation where, despite your best efforts, your screens get blinded and you just get bypassed. And how do you what's the real day in the life look like for someone who's got operational challenges like that?
So screen blinding is an absolute, can be a problem in any of those industries. There's two tricks that we have, and it has to be with the partners that we work with. The screens themselves are a 3-wire cloth, and they actually shake and they vibrate.
Okay.
So they are self-cleaning is kind of what they call it. Now, I use air quotes because you still can't get same size particle blindness, and from a same size. At that point, we would go to, there's a urethane screen that is a single layer cloth. It's a long life screen that with these machines we can use, and it's a single layer, and it's a wedge. It's not a wire. It's actually it's a patented for the guys we work with. It's a wedge, so if it's either bigger than the opener or small. We get a less production through that, but that can help with getting through areas that are sticky, that are this similar size. The other thing with blindness is it can be a chemical blindness. If you're using some of the flocculants, coagulants, we have to watch that. That's usually introduced after screening because you'll actually coat that screen like you would with like a snot type.
Yep.
You know, and you can change out these screens. They're usually minutes to change them out. It's not a, so if you do get a bugaboo, you can rectify that fairly quickly.
Any more questions for Jarrod?
Thank you very much for your
Thank
time.
you.